On the previous class, we learned about the working principle of full-stroke cycle petrol engine. Now I will discuss about the working principle of full-stroke cycle diesel engine. Here there is no carburetor, so only fresh atmospheric air comes into the cylinder. But at the first stage, as there is no atmospheric pressure difference between the inside and outside of the cylinder, so outside atmospheric air cannot come into the cylinder. But when we start engine, electric starting motor operates through Bendix drive operation for about 8 seconds. So here crankshaft rotate and the piston reciprocate inside the cylinder. So here inside the cylinder volume is increased and pressure decreases. And as inside the cylinder pressure decreases, so outside high pressure atmospheric air now comes into the cylinder and so suction start at constant pressure. This is A to 1. This is suction at constant pressure. When piston reaches from top dead center to bottom dead center, that means crankshaft from negative x to positive x. And when crank rotates from positive x to negative x, then the air inside the cylinder is now compressed. This is 1 to 2. And when air is compressed, inlet valve is closed, and at this time exhaust valve is also closed. So here isolated system creates, and as air is compressed, so heat is arised, and as there is no heat transfer, here reversible adiabatic process, that means isentropic process, is done. That means here compression is done in isentropic process. This is PV to the power gamma equal to C, 1 to 2. And when piston reaches near clearance volume, here from BDC to near clearance volume, due to compression, when heat is arised and very close to self-ignition temperature, that means the temperature at which diesel oil burns, then fuel valve injects diesel oil in the form of spray, and so combustion starts, and it continues up to TDC at constant pressure. Here 2 to 3 at constant pressure, 2 point, that is fuel valve open FVO, and 3 point, this is fuel valve closed. Now crank rotates from positive x to negative x, and due to rotation of the crank, piston again moves from TDC to BDC, and the flame in the clearance volume now expands, and work is done by the flame on the piston. So this is 3 to 4 expansion process, and it is also in PV to the power gamma equal to C, that is reversible adiabatic process or isentropic process. And when piston moves from TDC to BDC, the total heat energy is converted into mechanical work. That means indicated power is done. Now crank rotates from negative x to positive x. Now when crank rotate from positive x to negative x, that means piston moves from BDC to TDC, exhaust valve is opened, and now the burned gases escape out. At the first stage, the major part of the burned gases escape out due to its own expansion at constant volume. This is 4 to 1 dash. Volume equal to constant, exhaust first part. Yeah, and the rest is pushed by the piston at constant pressure. This is 1 to A dash at constant pressure. Yeah, and when piston reaches at TDC, exhaust stroke is completed. And again, when piston moves from EDC to BDC, inside the cylinder volume is decreased. And again, high pressure atmospheric air comes into the cylinder and suction is started. Yeah. So in this way, complete cycle is uh, included. This is suction, compression, combustion, expansion, and exhaust. That means 4-stroke cycle diesel engine. Yeah. On the next class, I will discuss about the steady flow energy equation. It is included in thermal engineering of third sem mechanical. Yeah. So thank you. Goodbye.